This video is going to be a continuation of our notes from the discriminant b squared minus 4ac. We're going to talk about simplifying our radical equations, or our square roots, radical expressions rather, if it's not a perfect square. Actually, we're going to talk about both, if it is and if it is not. So first of all, I want to go through some vocabulary. You don't need to write this unless you don't remember these words. But our radical, the radical sign is this part, and then the index, the number, is this part here. We are only going to do an index of 2. So when we do our roots, our square roots, we won't even put the index there. It's one of those invisible maths. When there is nothing written, it's understood to be a 2. And then this part here, the thing you are taking the root of, whoops, right there. This part here is called the radicand. So I'll use that word a lot. What ends up happening when we do our discriminant is we get that number, b squared minus 4ac, and then it becomes part of a square root in our quadratic formula. So that's why it is important for us to be able to simplify it down. So we're going to look at it in two cases. Case number one, we're going to draw kind of a little table here. Case number one is if the radicand is a perfect square, and case number two is if the radicand is not a perfect square. So the thing I'm taking the square root of, is it a perfect square or not? And you can just kind of split your paper in half for the two cases. Let's start with the it is a perfect square. If it is a perfect square, then you're just going to take the square root. And I just took a snippet of our perfect squares that we did up to 12 earlier in the unit. So for example, if it is the square root of 9, you look on the table and you're like, it's right here. So the square root of 9 is 3. And if I were to do the square root of 81, I would look right here. Don't know why I chose two multiples of 9, but that's okay. I would get 9. And if I asked you for negative square root of 121, then that would be right here. That would be negative 11. That negative's on the outside. So if it's a perfect square, it's actually pretty simple to do. You just need to use your chart or use your memory. Okay, now, if it's not a perfect square, what we are going to do is simplify it by looking for factors that are perfect squares. So for example, if I have the square root of 75. So if I look for the square root of 75, that would put me, if I were looking, that would put me like right between 8 and 9. It's not a perfect square. So what I'm going to do is think about what multiplies to 75. So 1 and 75, no, 2 doesn't go, 3 and 25. Oh, wait, 25 is a perfect square. So if I take this and I rewrite it as the square root of 3 times 25, because that's what 75 equals, I can do my square root of 25 is 5, my square root of 3 is 3. So my answer is still exact, but I pulled out this perfect square. So the square root of 25 is 5. The 3 is not a perfect square, and it's prime, so there's nothing, no perfect squares hidden in there. So it stays under the square root. Let's do another one. Let's do the square root of, let's go 700. So the square root of 700, hopefully you can see right away. Like sometimes it's just going to scream at you. Well, if I do 7 times 100, that's going to be a perfect square. Square root of 100 is 10. Square root of 7 is square root of 7. I can't do anything with that. So again, I'm trying to break it down and look for perfect squares that can be written as one of the factors, and then I can take the square root of that. Now, important note here, if I have the square root of a negative number, whether it's a perfect square or not, no real solution. I cannot do the perfect square. I cannot do the square root, whether it's perfect square or not a perfect square. So even if this were 23, I cannot do it with a negative number inside the square root.